Well, hello everybody, and welcome to today's webinar. My name is Chris Bouthiet from Siemens, and I'll be your webinar host coming to you from Glastonbury, Connecticut, here in the United States. As you may know, Siemens is a global company, so we have people joining us from all over the world today. Please take a minute to say hello in the chat window located on the right under the welcome slide, and let us know where you're joining from. Before we begin, I'd like to go over a few housekeeping items regarding the interface. At the bottom of your browser in the center, you'll see an icons in a widget dock, and these are interactive tools you will use throughout the webinar. You can minimize, maximize, and scale each widget to customize your viewing experience. I'd like to call your attention to the Q&A widget. The Q&A Ask Questions window should be open and is located in the center right under the camera that you're seeing me in right now. You're encouraged to submit questions to the presenter throughout the webinar using this widget. Your questions will disappear after you submit them, but we will see them on our side. Your questions will be answered during the live Q&A or offline after the webinar. On the far right of the widget panel, you'll see the Help widget. If you're experiencing any technical issues, please click on it for assistance. However, a quick refresh of your browser will solve most issues. Another note, the presentation is being recorded, and you will receive a link to view it in a follow-up email. So today we have our second webinar in our manufacturing series. If you missed the first one on closed-loop digital quality, I urge you to watch it using the provided link. Today, we are talking about modernizing our approach to NC programming through the use of the Siemens Accelerator platform, specifically NX, NXCAM, and Teamcenter. I think you'll find this is a really great approach that can offer significant advantages over the other disconnected systems you may have experience with. With that, I'd like to welcome and introduce our presenters today. We have Rick Murphy and Mark Anderson from Saratech, along with Michael Russell from Stretch Forming. You can find their bios in the bio widget. Just click on the little arrows to read more at any time. At this time, I'd like to hand it off to the team, so enjoy.
First slide, please. Thank you, Mark, and thank you, Chris. I'll go ahead and get started here. So thank you all for joining. This is Rick Murphy from Saratech, and today's topic is how to tackle the workforce and supply chain issues that we're all seeing is related to CNC program machine parts and products. As Chris already mentioned, you've seen our bios, and you're going to have access to this slide, I believe, maybe all of these slides, I believe, and you'll see our contact information if you'd like to get a hold of us sometime after this call. I've been at Saratech for over 6 years. I've been in the industry for over 35 years and have helped run different types of companies, and I help run Saratech at this time. Mark is our subject matter expert in this area, and he has over a couple decades worth of experience in CNC programming and through machining and really knowing how to make machines run really well and create great parts. And Mike Russell is at Stretch Form, and again, you'll see his bio there. Also, a couple of decades of experience. He helps run Stretch Form Corporation, and so he's experiencing these challenges in the market like many of you here. And so with that, we kind of like to get started with him so he can talk a little bit about that. Mike, next slide, please.
Great. Thanks for the introduction, Rick. So I want to address really what the issue we're seeing in the industry is right now. And it's primarily a lack of capacity. And really that's that's from the voice of the customer right now. We have customers coming on board and they're saying, hey, there's not enough capacity out in the supply chain. So we're getting this huge influx of new work, new customers, and we started having a bottleneck. We didn't have capacity on our engineering side to support onboarding all this new work. So initially we did what everyone normally does, and we started a hiring campaign and trying to find qualified manufacturing engineers and NC programmers. And I'm sure, a lot of people going through this right now. Very difficult to find qualified candidates. So we did that for about 6 months. We weren't having much success. And I said, we got to really kind of take a step back and rethink what we're doing here, because ultimately we have to solve this problem either way. And so what I came up with was, instead of hiring people, we need to take a look at our current process and figure out how we become more efficient in that current process. And that's where we kind of got tied in with Siemens and Saratech. And what we started looking at was, okay, so we have this current software that we're using. How can we look at other options out in the market to make us more efficient? So we switched to NX. And the big efficiency we saw was, first of all, the NC programming times were slashed almost half. Additionally, we had NC program validation with our digital twin. So using the software to validate our tool pass prior to cutting a first part. And that increased our first pass yield. So instead of doing a typical part tryout on the machine to validate everything was good, we can actually validate it digitally before we even cut a single chip, which also at the same time decreased our cost of quality, increased our profitability. Rick?
Yes, next slide, please.
Okay, great. Yeah, just a brief introduction here about stretch forming and who we are and what we do. We are a build-to-print contract manufacturer, primarily focused in the aerospace, defense, and space sectors. And the types of components we typically produce are large structural components for these types of industries. We are vertically integrated. We're located here in Paris, California, vertically integrated with metal forming, machining, fabrication, assembly, and heat treatment processes in-house. And there's a brief little description of some of our core customers there: Boeing, Lockheed, just, all the typical players.
Great, thanks, Mike. Next slide, please. Just a brief introduction to Saratech. We're an engineering and product development company, first and foremost. With that, we can develop complete products all the way through manufacturing. And often we'll also do services where we will just do a part of the product development process. And with that, and since we work with many different companies, with many in many different product areas, one of the things that we really focus on really is best practices and processes. And when we create those, then it's about repeatability. So we're going to talk a little bit more about that as we go. In most cases, we use Siemens software. That's our preferred software for most of our projects. Sometimes our customers require us to use other software. So many of you on the phone today may also be using other software, and again, we have to do that sometimes ourselves. And then when it comes to manufacturing, we go to partners like Stretchform Corporation if we get a design through build project, unless it's 3D printing. And in that case, we have our own 3D printers and really, industry scale level printers. And so we can produce those parts as well as Stretchform. We've actually partnered with them in that area as well. You can see at the bottom that we started here this list with aerospace and defense. That is also our largest market, but you can see we're in several other industries as well. Next slide, please. So digging into this problem in the or challenge that we're seeing in the industry, I'm probably preaching to the choir here. You all know what's going on out there, and a lot of this did start with the pandemic. Turning off the workers and turning off the supply chain obviously caused issues there that are still in place today. And the current administration has since then really been moving more and more manufacturing to the U.S. So this compounds the problems that we're seeing right now. And you can see, look at the spend in this Yahoo Finance reference in investing in more U.S. manufacturing construction has really, really spiked. So we can continue to see this problem grow. And then you see the reference here down below as well, that global military spending is surging amid war and rising tensions and insecurity. And I think we're all seeing that, especially in the defense, in our own defense industry here. So this ultimately trickles down to the component manufacturers, and we have literally 200 to 300 component manufacturers that we work with ourselves, and both Mark and I and others from the company go on site visits and walk the shop floors. And one of the things that we have seen that's pretty common is we've seen these beautiful CNC machines that cost hundreds of thousands, if not millions of dollars. They've got material stock, on the floor on a pallet waiting to be loaded into the machine. And it turns out, yeah, they've got a contract for that, for a project on that, but they don't have a CNC program. And so sometimes that's what we get brought in for, is to actually do the CNC programming for them, or help them with the technology so that they can do it better, faster, cheaper. And that's going to be part of what we're really going to show today, is how we've been able to really address this bottleneck that we're seeing in our customer base, and that we're hearing from the manufacturing industry. Next slide, please. And before we go there, Mike, I know that you, like, as you mentioned earlier, you were experiencing that. I mean, how long would it usually take once you got a contract and you brought it in, you got the requirements, you got the drawings? What did you have to do at that point to get to the point where you're first machining? How long did that take?
Yeah, so onboarding the business is the biggest challenge. I mean, it kind of depends on the scope on the contract and what you have to do. But let's just take a standard part that's a standard flow. It'd take us typically about 16 weeks, and the vast majority of that work is not actually making the part. It's consuming all the engineering requirements, creating all your fixturing and work holding, and generating NC programs.
Good. Thanks, Mike. And that's again what we're trying to address, is how can we work together, all of us work together and share our ideas and be able to do that better, faster, cheaper. So that's once you got a project. But what about before you all win different projects and RFPs? That process, we also understand, can also really take a lot of time and a lot of energy. And so that's what this slide is addressing here. And when we ask different customers, why is it taking so long? And they, we often hear, well, this is just kind of how we've always done it. We have to consume the information, like Mike mentioned, but to build that proposal, obviously we need to start doing a lot of estimating or guesstimating, right? And we have to estimate how long and how much time is it going to take us, and how much money it's going to cost us to do the NC program, estimate what the material costs are going to be, what it's going to take to make jigs and fixtures, and then actually get it into production, and so on. And so, if it's guesstimating, then, this whole process could be, and often can be, inefficient, and it could really have a lot of risk around the schedule and the cost, and be able to deliver the customer on time. And so, Mike, if I can ask you again, what do you see a typical bidding process take nowadays?
Again, depends on the package and the scope, but typically I'd say anywhere from 2 to 6 weeks. Again, this is where it all starts, the whole job here, right? So, at the end of the day, what you do on the front end here determines whether you make a profit or not when you get this contract. Anyone that's doing any type of job shop work knows it's all firm fixed price. So once you get that contract and that award, you have 5 to 10 days to accept or reject that contract, and then you got to perform with the price that you got. So the better job you do on the estimating side, the more likely you are to come out the other end profitable.
Which is key. Good. Thanks, Mike. Next slide, please, Mark. So the question, or the statement here is, what if there was a better way that you don't? It's that you kind of accessible and you can do it. Then this is something that should be explored. And so, what do we mean? Well, that ultimately it's about winning more RFPs and winning more of the right contracts. And if you have an optimized process and it's repeatable and it's managed meaning you do it, you can do it the same way no matter who in your organization's running that process. That's what you'd be looking at, and that you can leverage previous data. So if you have a system that ultimately is keeping track of how long did it take last time we did a product or a part that's similar to this, at least it gives you a reference for that. And then the time to program similar parts and machine setup, the creation of jigs and fixtures and the materials used. Again, so that this is about winning more projects by leveraging data and information that you've had in the past. Most people do use their experience and their tribal knowledge on how to do that. And so this what we're talking about here is great. How can you do even more of that faster? And then when you win the project, now it's about delivering on time and on budget. So you make the ultimately the profit that you were hoping to make. And so, as Mike had mentioned, that's where it comes down to, what if you can do faster NC programming, lower the cost of the creation of jigs and fixtures, and you could get the first part yield right where you want it to be, right the first time is ultimately what you want to get to, and higher quality results by the time you get to the CMM that you see your parts right on. So that's again what we're going to be talking and showing you a bit on today of how we think you can get there. At least we know that we're getting there with our customers. Next slide, please. So one of the things that, especially those of you that are on this call that are working for the big OEMs, whether they're in aerospace or automotive defense and so on, the words digital transformation have been going around a lot for several years. And I think it really accelerated. The conversations accelerated and started happening much more during, again, the pandemic, when we ended up with a distributed workforce that, at least in the product development area, was often working from home. And so the good news here is the software companies like Siemens, for example, have done a great job in really articulating what this means for this area of product development all the way through manufacturing and life cycle management. And they've invested in a lot of great software technology. They've either developed it themselves or they've acquired companies, and then they've been integrating that. But especially for those of you that are in suppliers and maybe not as big as these OEMs, probably look at this and go, oh my God, how are we ever going to do all of that? And the good news, in most cases, you probably don't need to do all of that, depending on your size. But there are certainly places to start, and that's where we're going to talk today about one of those places for you suppliers that are machining parts. A place you can start immediately. You don't have to have a 10-year plan to go and move to something like this now. Next slide. Great, thank you. In our experience, we start with the process, and I mentioned this a little bit earlier when I introduced our company. Since we're actually developing products on a day-to-day basis, like many of you on the phone, we're always looking for how can we do it better, faster, cheaper, and we often see that it's in the best practices of using the experts that we have and the expertise that we have and the technology that we have at our fingertips. But you can't just throw tools at this. You have to have the experts that know how to use it, and you have to have it being used in the right way, that doing the right thing at the right time. And often what you'll see is a lot of serial processes going on, meaning that somebody can't do their job until the person on their left has finished theirs. And so we're always looking for parallelism where we can actually maybe have several people at the same time, doing the piece that they need to do, but all in conjunction and all doing it with the same data and information and the same rev of the design and so on, making sure that everybody's in the right position at the right time. So we're going to, again, demonstrate some of that here in just a few minutes. Next slide, please.
Okay, I'll take it from here then, Rick. Thank you.
Yes, please do. Thank you.
So yeah, as Rick and Mike have been discussing, we have this standard process in industry, and it just is the way of the world. We haven't deviated from the standard practice very much over the last couple of decades. And this process has all these typical gaps in it. And some of those typical gaps are that we leave the parametric data of the model with the CAD software, and we start opening up our secondary CAM softwares. And we don't try to use any data that was in the original design model. We start at that point, and we then go and re-dictate to the CAM software all of the data that's in the model already. Other areas are project planning, NC programming. So there's very few times do you go in industry to where the standard practice of a CAM programmer or a job shop is to create operation realistic models. Meaning that if this part has 4 different setups to it, do we have an absolute iteration of how it's going to come out of op 1, op 2, op 3? Most times we don't do that. Most times we just allow the programmer to program to what operation 1 is going to end, and then we just use the in-process work piece of that part, or the end condition of the first part, to start our second part. And that just reinforces the straight line solution, where everybody's waiting for the previous person to get finished before the next person can continue. So one of those areas in the project planning side and the NC programming side is creating those realistic models so that we can really use the software to its fullest. Another area is post-processing. So it's difficult to have all post-processors and all simulation kits available to you at all times. It's very costly to build those types of libraries, but it's absolutely necessary to be able to do programming efficiently and accurately. And then, as Mike was saying in the beginning, to be able to verify and validate, we not only verify and validate, but we do it in the very beginning. So every time we hit generate to our toolpath, most people don't realize that all CAM systems, even third-party CAM systems, have the ability to use secondary or third options when it comes to generating toolpath. There may be other options available, but because there's no kinematic structure within the CAM program, it doesn't know that there is an issue or there is a secondary solution. So when you combine something that solves all these typical gaps, you really get a straight line solution that delivers. We've seen routinely 50% reduction in time. So we also, the very, very beginning of our process, it starts in our Team Center environment, which is our PLM, Product Lifecycle Management software. And it's far beyond just a data management software. So most of your data management softwares are typically just vaults. It's just a place where you check in and check out data, and it's just your design data. You're not necessarily your manufacturing data, or it's component parts. So the Team Center environment, it's fully comprehensive. It has everything from the project data, any type of revisions. It has all of our machine tools. It has all of our post-processors. It has links to tool vendors, to vendors who make fixturing, chucks, and things of that nature. So once it gets into our system, we know that it's being managed and it's valid to use. So everything is stored in one single location. We have dashboards that can show us the project health. We find things very easy. We just can search for them, and then it takes us to the location, and everything's managed. You check it in and check it out. Excuse me. So we also deploy digital threads. And what digital threads are is, it is a product fruition, our conception through fruition, within one single software that holds associativity from start to end, all managed within the PLM cycle, the PLM product. So this slide right here, this is going to show you the typical process that most manufacturers use. So we have this initial phase where, upon quote, the best we're able to do is search and scour our past databases for like projects, things that you can pull information like cut times and tooling, things of that nature. And you put it together in your best effort, but it always leaves a very large variant to actuals. So the only alternative to that is, as Mike was saying, with FFP contracts, we don't have a lot of luxury of making them snake up front and then coming back for any type of compensation afterwards. So we must do a large amount of effort up front to where we can really accurately do an FFP contract. So you have a lot of time, or you have tribal knowledge that isn't necessarily as accurate as we'd like. So the example down below, it's a consecutive approach. So say we did bid this job, it was quoted, we did win it. This particular example, it has 3 operations to it. So the typical process, as I was saying before, is it's released to your CAM department. Programmer 1 programs, 2 and 3 wait until 1 is done. 3 waits until 2 is done. Same thing for inspection. And that's just indicative of how the third-party softwares work as well. There's no real good piece to them that will allow a universal kickoff to every individual person. So what we've done at Saratech is, over the last 5 years, we've put a lot of effort into. We would ask my programmers, I would say, if you had a perfect world, if you had an unlimited charge number to where you could build whatever would make you efficient, or what would be the perfect situation? So we got together and we did that. We built those environments and those digital threads. The most important piece of a digital thread is the workflow. So without a workflow, the digital thread is non-functional. What a workflow is something indicative of, if your stock comes in from Alro, the certifications need checked into your check-in place. Something needs to tell programmers that stock has hit the floor. Once the programmer gets kickoff, then something needs to tell the management that it's actually been made. Those types of things are workflows. So another piece of this is stage modeling. So our software has stage modeling, which is those operation realistic models. We also have another piece called PMI, product manufacturing information. What that is it's a reallocation of effort. Instead of doing drafting secondary and downstream, that doesn't help us in our manufacturing process or our inspection process. It's just physically something that somebody can look at, measure, and then cross-reference and say yes or no. But it does nothing for us digitally. So what we do is we use the product manufacturing information, which is the same thing, just on a digital space. But what that does is that gives us an enormous amount of attributes. What that allows us to do is differentiate between a 312 hole and a 312 press fitted hole, or a slip fit hole, or just a through hole. So what this allows us to do is having realistic stage models, using the product manufacturing information the correct way. It not only allows for a simultaneous kickoff between all aspects of the part, but it allows us to turn loose the power of the software on the part. So instead of us having to go in as programmers and say, stop at that bottom level there, don't cut any further, we just tell the software to cut volume to volume, and it will stop at that ledge. So we're using the software's intelligence at our disposal. So what I'm showing here, this is Saratech digital thread technology. So what we do, we get an incoming quote. It has a workflow. Team Center has a workflow that will kick it off to our manufacturing engineering group. What our manufacturing engineering group does is, as I mentioned, over the last 5 years, we've created these highly comprehensive, intelligent libraries of machining practices, tooling, methodology, approach to a certain manufacturing principle, whether it's aerospace or tool and die or mold making. We have very specific digital threads that make it extremely efficient to work in that atmosphere. So what our manufacturing engineering department would do, they would run through sophisticated templating of stage modeling, to where they would interrogate the model and build the best fit stage model for that particular part within a set of restrictions and requirements that we built into the system. So then once it's ran through a system of feature-based manufacturing where it interrogates the model and then looks to those libraries, it automatically programs the part to that point. Then it goes to a peer review, to where it will go to a programmer. They will sit down and say, okay, go through the level of effort, add to, or sign off on that level of effort. Once it goes to the customer and they approve, it comes back to us. It bypasses manufacturing engineering and it goes directly to CAM, but it also goes directly to CMM at the same time. So our circular process, it makes it to where not only do we have accurate quotes based upon previous knowledge of actual tool paths, but we get a 75% finished program right from the beginning. So once we get the programs accepted, the quote accepted, and we actually start programming, we're much better ahead than just starting from scratch using, archaic tribal knowledge. And this is our actual kickoff. So once we get the release for manufacturing engineering, then it will go through and we will solidify the manufacturing engineering concept. Then it will be released wholeheartedly to the CAM and the inspection programming group. Fully simultaneous, all working within the team center environment, fully associative to the original master model. All right, let me show you a demo. So before I kick off into the demo, I'm going to show you a couple different things. I'm going to show you the original model with PMI. I'm going to show you what we call stage modeling, operation 1. Then I'm going to show you how we pass that PMI data off to the CMM to where it can automatically generate these inspection paths. And then if time allots, I have a replacement part to where I'll show you what it looks like from our perspective. One of the things that kills industry is getting revisions. So your current software, I've used all of them, so I'm very familiar with them. The best thing that you can do is copy a file, change the part, and then copy and paste toolpaths and reassociate geometries. There's a lot of manual intervention, a lot of room for error. And one of the strongest pieces of our software being fully associative is I can just do a general replace component, all toolpaths maintain, and we'll reattach, and a simple generation will catch them up. Sorry. Okay. Excuse me. So currently I have the part that you just saw there. As we're just to show you as we're going, this is how we start a file. We start a file with a digital twin. Whatever you're going to have in real life on your floor is what we're going to start with in programming, because it gives us the capability of when I say turn the software loose on something, it's because the nature of our software doesn't need manual intervention. We can say, do a roughing path. And if we don't tell it what surfaces to cut, it's going to cut everything from a blank to a finished part. So it's very intuitive in nature. So when we start with our tool, we have our machine tool, we do our direct setup, and then we just simply tell our software what is our part that we're cutting to, and then what is our blank. And then the software itself figures out the rest of it. So when we get to this point, though, you see we have a very realistic model of this operation. So instead of me having to go into this toolpath and say, stop at this level and do these manual interventions, I can just tell it to do a very sophisticated roughing toolpath that will cut stock to finished part. I can also tell it, I don't want to cut this vise at all. And it will give me toolpath that will omit any type of collision toolpath. So we're working very, very intelligently. Now, when we go in, one of the things that makes our software very unique also is we don't have to have any type of engagement or any type of supporting geometries for angles or motions as far as the machine tool is concerned. The machine tool knows that it has to approach from the Z-axis direction. And if we tell it to cut on this side of the part, it knows it has to force a rotation. So it's super intelligent. Now, when it comes to the Saratech digital thread, we've taken all of this and we've built them into a template to where I can ask the software, interrogate the model, go to our libraries, pick the correct fixture, pick the correct tooling package for that particular material, cycle through our library of machine tools, which is extensive, pick the best one that fits, start the setup, and then it will run in the feature-based manufacturing interrogation, and it will kick off going out to our libraries and our digital thread to complete the program. And I will be showing you an example of that shortly. Now, what this does also for the CMM, excuse me, is all we have to do is build the digital twin. This is the part that I want to inspect. All of its dimensions come from the PMI data that I showed you in the beginning. So the PMI data is all the GD and T. Because the machine tool itself knows this is its axis of orientation, the probe head can move independently in 360-degree motion. These are the inspection probes that it has available to it. All we have to do is set the environment, and then we use our link to PMI function. Our link to PMI is going to take all that into consideration. Any type of non-cutting motions, like don't hit the vise, don't hit the table, don't run out of stroke, and it will pick its own probe and it generate its own tool path. This is the tool path that it had generated, the probing inspection path that it had generated. Now we have full G-code-driven simulation here. So this is what Mike was talking about with the validating of the tool path digitally before we go to the machine tool. So what we've done is we create, traditionally with our programs, we create a safety validation move to where we will move this probe, and this here's our collision detection, but we will move this probe 100 thousandths above the center of this circle and stop with an M0. So if we can physically take our scale and it says 100 thousandths and we appear to be on position, then we know that our program is going to be correct. So all we have to do is validate setup, and we know our program is correct because we have a digital representation. So now I'm gonna actually walk you guys through what it looks like to run the digital thread. So here I have a part that needs to be made, just a simple part. We're going to go out and select one of our templates. We'll just use our general. Excuse me. So all we have to do is tell our system, what are we cutting? What are we cutting from? Give it some material on the top. And then where is its zero location? We'll just tell it it's the top of the blank. And now we can turn loose the software on the part utilizing our libraries. We're asking the software, interrogate the model. The machining axis direction is coming from this way. And we want to use the entire workpiece. So now you're going to see this lower bar down here is interrogating the model at this moment. It says, I understand what all of these features are. Now we just have to ask it to run through the libraries. We can have different selections, different types of parameters we can check, uncheck. We can limit operation types. And now it's running out to the library, taking operations, going to the tool data library. It's pairing tools with operations that have created these tool paths here. So now once I generate them and update them, you can tell by just watching that this is not a software probably that you're used to seeing. There is no type of construction. I didn't do any type of organization. I just asked the software to do what it does with my digital thread in the background. The software says, I'm fully aware of everything that was just done. And this is the side of things that I say our traditional process is broken from the very beginning. If you were to sit down and ask your programmers, how many times in your career have you programmed a half 13 tap tool? Most people will say tens of thousands. If it takes 5 minutes to do that, that's tens of thousands of 5 minutes per person. That's a lot of time spent doing tasks that the model itself already knows that this counter board has all of those attributes to it. When we go kicking out step files and parasolids to bring into third-party softwares, all of that's gone. Now we have to do it ourselves. So this is how we get this automation to run, how we get those libraries to function. I could tell it that this particular hole, I could just, by simply putting a PMI symbol of a 10 finish on that, these may pull an insert drill, and this one may pull a 7 tool operation set to get a fine finish. So just by minimal work, we teach the software what things are, and then it just interrogates it later, and then it auto processes what we have done previously, so that when we develop toolpaths, we know that they are the most sophisticated toolpaths out there. They have the best tooling, and they are the fastest. The only thing we have to do now is stay up on tool technology. If a new tool comes out that says it's quicker than the old tool, then we have to test, and then we just implement that now in our process. So our software is so intelligent that it says this particular feature has no radius in this corner. It cannot be cut by a rotating tool. So it gave me a wire EDM toolpath. So it's extremely sophisticated software. So now what we would do, I have a completed program here. So I'm sorry, this one has the simulation kit. So what I just showed you, it does not have the G-code driven simulation within it. This one does. So this one's set up exactly as I would program a real part. But now by doing the exact same thing that I just once did, what am I cutting? What am I cutting from? Running feature-based manufacturing, identifying our library, which ones we wanted to attack, how we would like to attack the part. The difference being the last program was programmed much like you program now, many of you program now, where there's no analytics behind. Is this toolpath capable of making these motions within the tool, within the machine tool? So now, this time when I generate, it's taking all of them into consideration. There will not be any type of approach errors, exit errors, collisions, gouges. There won't be over travels. There won't be any type of machine tool characteristic that many times there's a well-known software out there that most people do all of their simulations in, their G-code driven simulations. It makes it a very straight line solution. You get out to that software and it says, no, it's wrong. It doesn't say where it's wrong in your CAM software. You have to go back through and figure it out. Then you process it again. And what if it was wrong just in the next operation? You may cycle through this 3, 4, 5 times. Every time that we hit generate, all of them are taken into consideration. It is only when there's not a solution that couldn't be found that it will still produce an error toolpath. So ours is a straight line solution. So now right here, without any other software, we're in G-code driven simulation. Here's our actual machine code that's running. It's a highly sophisticated environment. Excuse me. So now here is the most important piece. So many times you could have just submitted your project as complete, and then they send you a revision. And then how do you recover from a revision at engineering change order? So most all of your softwares have no connection between CAD and CAM. So the best you're able to do is make a new program, RevB, with the new part, and then copy operations like this to the new one, and then open each one, select the new geometry. So what our software is capable of doing is, reason why no software can do a replacement is because when you parasolid out a file or you step out a file, you just think of it as an enormous Excel sheet with letters and columns. All of the data of this file is just dispersed through letters and columns. When you bring it back into a software, it has an encryption key that's parasolid or step that tells it where to go back to. If you were to do a revision of a part, export a parasolid, there's no guarantee that it's going to go back in the same places. So there's no associativity between it. With our software, everything remains 100% identical. So here's our Rev 2. If I would show you this view, you see my whole alignments here. Here is Rev 1. And you can see its whole alignments here. So all I have to do is come here to our assembly, place the component to the revision, update my file, regenerate my toolpath. Everything stays 100% associative. And that will also propagate out through CMM, anything that has this original master model to it. So then we would complete it by doing our customized setup instructions. This is how we communicate to our customers. It's fully comprehensive setup sheets that tell how the part's set up, what the tool path does, what the tool lengths, numbers, all of the data that's needed for a proper setup of a machine tool. And through the utilization of the Saratech digital thread from our team center environment that is unique to that industry, to all of our machine tools, our fixtures, our tool vendor catalogs, and the methodology of our stage modeling templates, we're able to rapidly produce NC programs. We're rapidly able to recover from engineering change orders, and we have full revision control over everything that we do. But you can see this is a very analytic process. It's pulling all this data from the NX solution, and it produces a very nice PDF file. And all of this data that you've seen me do, all of the setup files, all of the part files, this setup sheet, all of the machine tools, all of the tools, all of the fixtures, that's all housed within our team center environment. So this is the process of the Saratech digital thread. So with that, I'll kick that over to my friend Mike Russell at Stretchform.
Fantastic. Thanks, Mark. So just a brief slide on what our typical process before the transformation was. I'm sure this is going to look pretty typical to most people on this. We started with the quote, which we discussed. We always receive a contract in response to that quote. Then you have your contract review process. Planning a product realization, probably one of the most critical elements there is actually defining how you're going to manufacture that product start to finish. And then we formalize that on our shop traveler. We complete our NC programming, which would include any of the tooling fixturing necessary, and then our first part runoff. Next slide, please. And most importantly here, this is going to just talking about where we've seen the ROI on this transformation. In most cases, we're seeing a reduced lead time delivery to our customers about 50%. Another key thing we've started doing is being able to work in native data sets. So a lot of our customers are designing aircraft in NX. So having that native data set eliminates the need to make an investment in translation verification. So you need a totally separate software to do that, and you lose some of the MBD translation as well. So working in the native data set is key, and it's a great marketing tool as well to the customer. We're getting much faster toolpath generation. We've seen on average about 90% reduction on some of these more larger complex parts. So that was one of the real pains for me, was sitting around and watching my programmer stare at a screen while the toolpaths generate, paying him hourly. So reducing that's had a significant cost savings for us. Utilizing feature-based machining, kind of like Mark described there, that significantly reduced our NC programming time. That's how we're achieving some of these reduced lead times for the manufacturing cycle by 50%. And then lastly, kind of like how I discussed, we have integrated simulation and digital twin, right? It's allowing us to validate the tool pass. So we get back into that first pass yield. We're going to get a part off the machine the first time, every time. Now, that's critical, especially when you start talking about some of these higher cost materials. I mean, if you're machining larger forged titanium forgings, or some of the more exotic aluminum lithe materials that we're seeing out there right now, there's a significant cost savings if you're not having to do a part tryout and scrapping a part. And then additionally, when you do run that verification, it allows you to optimize the tool pass, because you're getting feedback saying, hey, these are your cycle times. And if it's not close to what you quoted, say, hey, how can we go back and take a look at these tool paths and optimize them so we can get closer to the times that we quoted as well. Thank you.
Thank you, Mike. Next slide, please, Mark. Great. So we this concludes, other than a little bit of time for any questions if you have those. But we just want to know that we're all here to help. We're partnering with Stretch Form, Siemens, and the Connex marketplace that many of you heard about this webinar from. So, let us know if there's something we can do. If you just have any questions, we'd be happy to answer those. And again, our contact information was on the slide with the bios. Next slide, Mark. All right. And Lynn, I think would you manage if there's any questions?
Yeah. So thanks, guys, for the presentation. That was fantastic. Mark, really powerful demo. Really loved the material. So thanks for presenting today. If you have any questions, you can pop them over in the Q&A chat. We do have one question so far. Do you completely rebuild, remodel a customer's CAD model into the NX to utilize feature recognition? Like, for instance, if they're provided a step or a parasolid model from the customer, do you go in and remodel it in NX and then add the PMI as well?
Oh, that's a very good question. So no, what we're capable of doing is we can bring it in any secondary type of file, whether it's parasolid, step, and then once we save that, it becomes an NX data set. Then after that, we would just apply our PMI data to that. So it would be no different than dimensioning it like for a draft. But that goes hand in hand with me saying it's just a reallocation of effort. So most of the pushback that we see in industry when we discuss PMI is that, well, that just adds another step of work for my designer. You have to think about it the other direction. You have to say it's just a reallocation of it. So the 4 hours that it took you to develop that draft, that does nothing for us other than to view it. Now we just redirect that 4 hours into PMI data, but that PMI data reduced our CAM programming and or CMM programming by 80%. So it's just a matter of reallocation of effort, but unless it's absolutely corrupted data coming in for the model or something of that nature to where a PMI wasn't able to attach to an entity, there wouldn't be any type of remodeling.
Thank you. The first time I saw this, I was doing a demo with Mark to a customer who was using Mastercam, and they were quite embedded into Mastercam. They had 20-something NC programmers, and right off the bat they're like, no, we're not switching from Mastercam. And then after we went through it and really explained to them the benefits, they immediately sort of turned around, and that's what I really wanted to get this in front of all of you all, because I think they could immediately see the value that this was going to create, even though they would have to sort of retrain people and get them onto NX. But I think that investment in that time is going to pay back tenfold over the amount of time. I don't know if you guys have any thoughts on that.
No, you're absolutely right. Those two are the two first statements that we get with customers who have third-party softwares that are really embedded with them is, one, it's an enormous amount of effort to get people retrained into another software. And then on top of that, to build a feature-based manufacturing system of libraries with tooling and things of that nature to be, the most efficient that you possibly can be. Yes, there is training and things of that nature, but if you look at ROI, it's well within the first year. And then every other year after that, it's just profit. So the one thing that I would like to iterate to everyone is the second piece of that is we can't do this ourselves. I know that we're not coders, we're not people who can, make systems or anything like that. And we have to make product every single day. I don't know how that fits into how do we continue going. As a Saratech, we have done this many, many times, and we put together programs to where it's a success plan. It could be months, it could be years, but it will build to fit your need.
I can speak to that as well. I can speak to that as well. This is Mike with Stretch Form. So effectively, by moving from the old software which we were using and transitioning to NX CAM, I was actually able to not just add so much capacity, but cut my entire staff in the programming office in half by moving to that software. So the ROI is there, absolutely.
Yeah. Do you need to have an NX CAD license and a CAM license, or can they just do it with NX CAM?
So to use the software to its full capabilities, and what I had demonstrated, you would need a full CAD CAM C. So that the nature of CAM softwares, traditionally people, they don't realize that they need a CAD piece to be able to efficiently perform the CAM piece. They go out to third-party softwares when they're trying to develop something like a drive curve for 5-axis programming or something like that. And they tell a designer, will you give me this sheet? And then they program to it. With our software, NX, the reason why it is so capable is because it's not many softwares. It's one software, different modules. And we can rapidly and quickly move between them to develop these CAD pieces that help us in our CAM. So to do what I've showed you today, it does require a CAD CAM license.
Yeah. Thank you. Again, I think this is so powerful. And I'm living here in the Connecticut area. There's so many, little companies supporting the big OEMs. Like here in Connecticut, we have Sikorsky and Pratt & Whitney and Collins Aerospace, and so many of them are using these sort of disconnected systems. And every day for the last 20 years, all I've heard is, oh, you can't find any good programmers. I can't find any programmers. I can't grow my business today because I can't find any programmers. We're just strapped resources. And, that's really why I wanted to bring this message to you guys today. And really, thank you to Saratech and Stretchform for coming out here and, really showing us what's possible.
Yeah, absolutely. You're welcome.